Calculating the area under a curve using Riemann sums. So our equation for Riemann sums is the limit as n approaches infinity, and n is your number of rectangles in the shape, and the summation, so the limit of the summation f is your function, whichever function they'll give you, f at xi times delta x. Now, delta x is equal to b minus a over n, and again n here, n and n, two number of rectangles. This portion is equal to a, which they'll give you, plus delta x, which is over there, times I. Now in this specific equation, our function is y equals x cubed minus 6x. A is equal to 0 and b is equal to 3. Now they don't give us an n value, but that's okay. First we're going to calculate our x sub I. So we can sub it in to delta x. So I can color this yellow. X sub I is this, x sub I. Okay, so that was a, our a here is 0, plus delta x, which is b minus a over n, times I. Now b is 3, a is 0, and n we don't know, so we'll do 3 minus 0 over n times I, which is 3i divided by n. Okay? So 3i over n, that is our x sub I. So when we're going to do f at x sub I, we will sub 3i over n into our function here, anywhere there's an x. So now we're going to calculate delta x. We already did that, but I'll just do that again over here. So this delta x in purple, we're going to calculate it down here. So delta x, remember, it was b minus a over n. Normally you should just calculate delta x first, and you can use it in here. It's the same thing, b minus a over n. So you have 3 minus 0 divided by n, which is just 3 over n. So now we're going to sub all of this into our equation. So we have the limit as n approaches infinity, the summation of, okay, f at x sub I. X sub I is 3i over n, and f at that number means everywhere there is an x, you're going to sub 3i over n. So we're going to have 3i over n. Actually, this should be in yellow. 3i over n. See, instead of x, I'm going to put that cubed minus 6 times 3i over n. And now just close bracket. And times delta x, which was in purple. Now remember, delta x is 3 over n, so we'll have times 3 over n. So now we are just going to expand this out. So equals limit as, this is tedious, but you have to write it every time. Limit as n approaches infinity, summation. Okay, now 3i over n cubed minus 6 times 3i over n, you're going to simplify that, and it's going to become 27i cubed over n cubed minus 18i over n times this 3 over n. Now we can split it up, so we will have the same thing again. Now I'm going to bring the 3 over n out front. So this 3 over n, this 3 over n will come here. And I'm only going to take this first term, 27 I cubed over n cubed, because I'm splitting up the sums. So 27I cubed over n cubed, 27I cubed over n cubed. So we have this minus the limit and now I'm going to bring the 3 over n into this as well and multiply it by this 18I over n. Now you don't have to put negative 18I over n because we already accounted for the negative right here. Okay, so now you have split it up. Now we only want to keep the I term in front of our limit. Everything else has to stay outside the limit. So this I term has to stay, and this has to stay. And actually, these 3 over n that I put should actually go right here. They should go right here. But, outside the limit. Or no, sorry, not outside the limit. Outside the, not outside the limit. This one just has to go outside the summation. Right. So, right here. Okay. So in our next step, hold on 1 second. Right, so in our next step, we're going to do the limit infinity. Now this 3 over n is going to stay out here. And now remember, we only want to keep the I cubed in here, only the I terms. So the 27 over I cubed, or 27 over n cubed is going to come out. And inside our brackets, we're just going to keep the, or not even brackets anymore, we're just going to keep the I cubed there. We don't need brackets. Yellow. I cubed. Now, that's all this part. Now we're going to subtract this limit. So limit as n approaches infinity. I'm just going to start erasing some of it because we don't need this extra stuff because we know what to do now. So I have some room. Okay. So you have the limit as n approaches infinity. Now the 3 over n is still going to stay out there. And now we are going to multiply by the 18 over n. We're bringing it out of the brackets and just keeping the I here. Now we're going to keep the summation and only keep our I. Now from this whole term, we're going to multiply these numbers together. So we keep limit. Now I'm just going to use yellow for the whole thing. 3 times 27 is going to be 81, and n times n cubed will be n to the 4. So we're going to keep that there. And then the summation of I cubed. Now, this summation of I cubed, the formula, there are specific formulas. So this one will be n plus 1, 2n plus 1, all over 6. So now you don't need this summation symbol anymore because this whole thing became this. So the summation of I cubed is this whole thing. So you're going to keep everything else on this side the same too. So this limit stays the same. 3 over n times 18 So 18 times 3, and then n times n, so 54 divided by n squared. Now you don't need this summation anymore. So for this, actually I should circle this whole thing is this formula. So not just the I cubed. So same thing here. This whole thing is going to be my n plus 1 divided by 2. Now I'm going to clear this whole thing. Just going to quickly erase it because I need a blank sheet. Or I'll just erase the top couple of steps. This is mostly done with polynomials. There may be harder functions such as e to the x and stuff, or sine x, but they would have to give you summation formulas. We only have formulas in general for I squared, and I cubed. So anything else is a bit more complicated, so most teachers don't give that on like basic integration with Riemann sum questions. Okay, so I'm going to put our new steps in green so we make sure, don't get confused that these are not the steps before this, these are the steps after. So now everything is going to come up in green. So I'm going to make a little line here. Okay, so after all of this, we have the limit as n approaches infinity. Now you're going to just expand everything out, just multiply it all out. You're going to end up with 81 over n to the 4 times n to the 4 plus n squared plus 2n cubed all over 4 minus the limit as n approaches infinity of, let me just erase this little arrow. Limit as n approaches infinity of 54 over n squared times n squared plus n divided by 2. Okay, so now we have, it does not become n squared plus n divided by 2. When we simplify it, it becomes something else. So you have 54, actually, 1 second. Okay, so you'd actually have 54 n squared plus 54 n over 2n squared. Now assuming you've taken calculus 1, so computing limits that go to infinity means you need to multiply this 81 over n to the 4 out with each of these, so you'll have 81 over n to the 4 times n to the 4 plus 81 over n to the 4 times n to the 2 plus 81 over n to the 4 times 2n cubed, and also multiply 4 by the n to the 4. So multiply everything out, and then over here multiply everything out. Well, it's already multiplied out on this side actually, but over here you multiply it all out, and once you do that, you split up your fractions. So you would have 81 n to the 4 over n to the 4 plus 81 n squared over n to the 4. So I'm actually just going to write that. So you're going to have the limit as n approaches. Okay, so you'll have limit as n approaches infinity. Now 81 n to the 4 over 4n to the 4. Now when you're doing this, from here you can multiply it out. You can do limit as n approaches infinity of 81 n to the 4 over 4n to the 4 plus 81 n squared over 4n to the 4 plus blah blah blah. For each of these, split them up, minus the limit as n approaches infinity 54n squared over 2n squared plus 54 over 2n squared. Okay? And okay, so once you split everything up, what you're going to see, well, what's going to happen is they're just going to end up canceling. N to the 4 and n to the 4 cancel. Everything else that's below this, like n squared over n to the 4, they'd cancel, but on the denominator you'd still have an n term left over. So when you find the limit to infinity, it's just going to be 0. So anything after this first term, once the n to the 4 and n to the 4 cancel, everything else would just be going to 0 because the n's would not cancel. So this would all go to 0. And then on this side, you have 54 over 2, which you can divide to make 27. And then this is actually 20.25 when you divide 81 over 4. N squared cancel. Yeah, the n squared and n squared cancel, so you'd have 54 over 2, which is just 27. See here, here 54 and 2, that becomes 27, but you'd still have an n squared on the bottom, so this whole term will be going to 0 when you find the limits to infinity. So when you actually compute the limits, I'm just going to put my final step in red. So I'm just going to put the final answer here. So when you find the limit as n approaches infinity here, so you remember everything else will cancel except 81 over 4. So you'll have this minus this 27. Okay, so that should be negative 6.75 as your answer. If you have any comments, leave them in the comments section below. Thank you.